Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fifth lecture of Module 11 on Geomorphology of Sea, Seashore, Shoreline Engineering Geology, Hazards and Mitigation. In previous lectures, we have discussed about different types of sea waves, categorization of sea waves as deep water waves and shallow water waves, and changes in characteristic of waves with respect to depth of water. Now in these lectures we will discuss about harmful impact of sea waves on coastal zones or seashore, mitigation of hazards induced by sea waves and protective engineering structures. In these lectures we are going to elaborate about seashore hazards, mitigations and protective structures. Regarding these lectures we are going to cover about introductory part related to harmful effect of sea waves, then about the types of hazards, mitigation, protective structures, classification of protective engineering structures and work of protective structures as economical consideration. Friends, as you know, the shoreline changes induced by erosion and accretion are natural processes that take place over a range of time scale, and the coastal zone is the most geologically active zone on the earth. Why? Because the coastal process in this zone may result to erosion, submergence and the saltwater intrusion. Different activities are going on along the coastal zone. Therefore, this coastal zone is considered a geologically active zone in our earth history. On earth in present time, coastal area globally suffered by serious erosion and sedimentation problem. And these hazards may arise in response to short term such as storms, waves action, tides, winds, or in response to the long term events such as glaciation, orogenic cycles, tectonics, etc., which may significantly alter sea levels, and tectonic events that result coastal land subsidence or emergence. C. Owing to combination of various natural forces, population growth and unmanaged economical development along the coast, within the river catchment and offshores, leading to many hazardous impact. This kind of problems you can observe in various countries like China, like Japan, like India, Indonesia, Vietnam, Sri Lanka, Thailand, Bangladesh and Malaysia. Besides this, other part of world having coastal zone are also feeling such type of serious problem. The coastal erosion is one of most severe hazards associated with sea coast, and it is responsible for loss of subaerial landmass to sea due to natural processes such as waves, currents and tides. These agents are going to create forces for erosional work as well as sedimentation. The forces of waves and currents tend to move the rock fragments, sands and soils from the shore. Such type of movement of rock fragments, sand, soil from the shore toward the offshore is a major problem in front of researcher and scientists. Such kinds of force result slowly the erosion of landmass. The continuous erosion of landmass brings changes in both the size and shape and features of coast. If we are going to see here, one remarkable statement is the erosional influence does not cause instantaneous destruction like tsunami. The tsunami is associated with earthquake occurring in the seabed, creating a massive release of energy and material, causing a storm-like effect and more damage to the nearby area. Although some people also compare this tsunami as tide action, but the tidal action is different than the tsunami. Slow down and preventive structures are going to support the protection of coastal zone. Hence, most coastlines are naturally dynamic and cycle of origins are a significant features of their topographical as well as ecological attributes or characteristics. Coastal lines are highly dynamic natural systems that interact with the terrestrial, marine and atmospheric processes and undergo continuous change in response to these processes. Therefore, we are going to recognize the coastal zone as a dynamic in state. Wind waves, currents and natural forces that easily remove the unconsolidated sand, soils and weak and fracture rock strata in the coastal area, resulting in rapid change in the position, shape and features of shorelines. Coastal erosion is one of principal problems facing coastal engineers and scientists and communities residing in nearby coastal zone and feeling lot of fears due to such intense erosional impact. The main activity along the coast, within the river catchment area, watershed and offshore, in combination with these natural forces frequently aggravated the coastal erosion in several locations and endangered chances for the coast to fulfill their socio-economical and ecological role in long term as a reasonable societal cost. Over the year, human society has often failed to recognize the hazards related due to the dynamic nature, and this lead to the major disasters in future. Therefore, the assessment of coastal erosion risk is a fundamental for better coastal management. If we are going to see particularly coastal erosion, then we have to ask these three questions. What is the hazard? What is the risk? And how to manage this risk? Three questions about hazards, about risk and the structure of management. Managing coastal erosion risk in coastal zone involves an integrated approach or a combination of the major structural control, environmental control and regulatory and policy control. These three types of control going to minimize such hazardous impact caused by sea waves near the coastal zone. In major structural controls, we have hard erosional control structures, that is the engineering structure, and such type of hard engineering structure is going to divert the flow of water, observe the impact of sea waves and minimize the energy of sea waves. Limiting development in erosion hazards area and other protective land use methods can reduce the risk of coastal erosion. Therefore, we have number of engineering structures which are going to support the stability of coastal zone and going to minimize the impact of such hazardous erosional impact. Environmental control, this is the soft techniques or natural techniques involving some artificial measures. The beach nourishment is commonly done by adding sand to the shore to extend their houses, hotels and other recreational facilities. Likely beach dewatering is another method to avoid erosion, and it involves pumping out water from the shore. Besides this, the peoples are practicing plantation of different varieties of tree, plants and grasses to protect the coastal zone from environmental point of view. Regulatory and policy control is related to construction permit, which are often required to construct or modify existing structure, incorporate coastal erosion management regulations to ensure that any type of building activities or construction work will not accelerate shoreline erosion. In this way, making hard engineering structure environmental sensitive controlled structure and regulatory and policy control going to minimize such impact due to reduction in erosion of coastal zone. Particularly in environmental control measures mainly includes the beach nourishment. This process is concerned to the placing of sand to the shore area or on beach area to increase the elevation and distance between the upland area and the shoreline. This creates a buffer or a protective zone that diverts storms and wave energy before they hit formerly eroding area and reducing the risk of flood and the dune erosion. Vegetation is commonly planted on the beaches, dunes and unstable shoreline to anchor or strengthen the sand or soil or even rock strata present in a particular place or in locality. The shoreline are made up of plants, sand, soils in combination with the hard structures such as riprap or gabions are utilized to stabilize the shoreline, prevent erosion and maintain wildlife and marine habitats from ecological point of view. Constructed wetland are new or restored tidal wetland using plants to anchor the soil or fractured rock mass or prevent erosion and create wildlife habitats. And the vegetated islands are either fixed or floating offshore structure such as anchored mat or infill islands that provide ecological benefit and can minimize erosion caused by breaking waves. Therefore, the mitigation of such hazards are very important to save the coastal zone for protecting various facets of sea coast. Regarding the mitigations, particularly the hard engineering structure or hard engineering control, we are going to develop these 4 type of structure which are going to help in mitigation of such hazards. The mitigation of such hazardous impact on sea coast is carried out in these 4 ways. First, by diverting the direction of wave impact, reducing the energy of waves, dividing the energy of waves and absorbing the energy of. Here, if we are going to develop any structure, such protective structures, we are going to categorize a class of structure that going to divert the direction of wave. Second type of structures which are going to reduce the energy of waves or currents, and third is dividing the energy of wave, and fourth, observing energy of waves. In this way, we are going to plan to protect the sea coast by making different hard engineering structures, and the coastal structures are constructed to prevent impact of erosion on coastal landscapes and infrastructures and mitigate the risk to the population and economical activities depend on the coastal zone. Enhance the increased access or marine site and support coastal subdivisions like infrastructure concerned to the power poles, stormwater pipes and others, lighthouse and others. So, considering such type of diverting direction, reducing energy, dividing energy and observing energy of sea waves, we have different structures belonging to first type hard engineering structures and second type soft engineering structure or naturally formed engineering structure such as formation of dunes and others. All these two either belongs to diverting structures, either absorbing structures, either reducing the energy of the waves, etc. Here we are more concerned about development of the hard engineering structure. These hard engineering structures either belonging to the divergent structure, either belonging to the reducing structure, either belonging to the absorbing structures. These are made up of hard and rigid material, therefore called as hard engineering structures. The material used for construction of such structures are concrete, masonry, large armored stone, steel or timber. These are relatively permanent and fixed for minimum life of 50 years. However, some of these structures are temporary and mobile in nature, transfer from one place to another place depending on the requirement. These are especially fixed within dynamic coastal zone recognized as the hard fixed engineering structure. The most important hard structures are categorized by the term groins, gabions, breakwater structures, retaining wall structure, sand dunes and jetties. These are common hard engineering structure except sand dunes. Hard engineering structure widely utilized along the coastal zone to mitigate the impact of hazardous erosional impact. So what is the groins? The groins belongs to the hard engineering structure. It is a rigid hydraulic structures built perpendicularly from an ocean shore or a river bank if we are studying the river related problem. So the rigid structure made up of concrete located perpendicular from an ocean or seashore is recognized as groins. Then what is the other features? These structures constructed at an angle to the flow in order to deflect the flowing water away as a diverting structure from critical zone or the zone highly affected by erosional impact. These structures obstruct flow of water and limiting the movement of sediments. In this way, this structure is going to minimize the erosional impact. It is usually made up of wood, concrete or stone. It is a little barrier placed generally at right angle, that is 1 meter to 2 meter above the high tide lines and extending nearly 50 meter from the beach. The length of groin should be 50% longer than that of beach. This type of structure is suitable to minimize the impact of erosion, particularly in a beach area. And the length of groins, as we have analyzed, it is 50%. Less than 50% is not suitable and creating a lot of problem. The purpose of Groyan's construction is to capture the sand which will be taken away by the longshore currents or other agents acting nearby the shore zone. The sand that are carried away from the beach area by currents are stopped on the upcurrent sides and can be raised to restore the shore zone. The groyans are very costly for the beach protection as they do not require maintenance and they do not protect beach against storm. This is the limitation. If we are going to see this groyans structure, it is a very simple structures were working. The propagation of westward waves. Here the waves are coming. The waves are coming from the deep sea area toward the shore, going to strike the shore and create lot of erosional problem. Such type of structure is going to break the energy of waves ready to erode the coastal zone. So the waves are coming in this way and this curve profile is going to enhance the height of this wave and finally this wave become unstable and going to break in number of wavelets with low energy impact. If certain waves are even able to cross this, then the another cage is going to break this. In this way, this structure is going to divide the energy of the waves which are going to interact with coastal zone and creating erosional problem. So such type of number of structures going to finally minimize the impact and not allowing any drop of sediments to move towards the offshore side. So the piers is going to barrier the movement of sediments along with the currents in returning waves and in this way we are able to protect the coastal zone. This heavy structure you can see the number of such structures. These structures is going to create here. This type of structures is actually extended here like this and this base side is here we are getting and this supports, different supports is going to protect such type of structures containing this type of sections. This structure is known as groyans. Groyans are widely utilized in coastal zone regarding the protection of coastal zone from the hazardous impact of erosion. Next structure is the gabions and the gabions is a very economical structures, not costly. It is a simple structure. When the waves is going to strike such structure, the some amount of water enter inside this structure because this structure is a very simple. The gabions are made up of boulders and rock fragments encased within the fabricated frame of wires like this. For this we are going to make one such type of net hard structures and taking the benefit of this boulders and cobbles and others fill inside and make the whole structures semi-rigid. Lot of spaces are available within the boulders. If the water along with sediments enter inside this cage, then because in forward movement the energy may be high, but during return phase of the water, the energy is of reduced nature, unable to carry the sediments from this coastal zone, and this type of structure is going to protect the movement of sediments carried out from the central zone. On one side, on another side, this structure is going to reduce or absorb the energy of the waves. This type of structure is a very economical and easy. It may be of square cross section, it may be of hexagonal section. The hexagonal section is technically more useful in case of protection concerned to the coastal zone subjected to erosional impact. Such type of gabion structures we are utilizing particularly in coastal zone. Why? Because this angular interface is partially going to break the energy of waves or divide the energy of waves into direction. If this zone we are going to put, suppose this waves is coming in this direction and we are going to put this type of structure in way of waves, then the angular portion which is act as divider type of structure going to break some of the waves towards up, some of the wave towards down, and in this way going to divide the energy of waves in 2 or 3 components. When the waves is going to interact this corner zone of hexa, therefore the hexagonal framework or hexagonal sectional framework of the gabions are found most suitable to divert or divide the energy of wave, divert the wave direction, as well as absorb the energy of waves and protect the movement of sediments from this coastal zone towards the offshore zone. The gabions are usually used in an area vulnerable to flood or even utilized in landslide also, protection of landslide. Very simple structure. It is placed at right angle to the beach face, and when the ocean water break on the gabions, water drain through the leaving the sediments inside this structure, and the rocks and boulder absorbs a moderate amount of energy of waves as absorbing structure, and it need to be tight to prevent abrasion by the rock detachment from the wire and the hexagonal wire masonry concrete wall structures found suitable. But limitation is here due to continuous interaction of saline water to the iron wires requires time to time replacement and repair and careful monitoring to ensure the proper working of such protective structure. Another structure is a water break structure, although this also water break structures, but the structure only utilized to break the water, you can see very simple. We are going to make some protection here at the toe of structure made up of either concrete, either masonry, here either concrete, either masonry as a core, and number of boulders are fixed on the top. This is the armored layer, this is the armored layer, and this is the bottom layer or the upper part of the core. This armor layer is covered by boulders. When the water waves coming from the deep side and going to strike, then this type of structure is going to break the energy of waves. Then this whole waves is going to interact with the boulders present on the armor's layer, and these boulders are going to break the wave are in another way going to reduce the energy of the waves. In this way going to reduce the hazardous impact of such waves going to strike on sea coast. The number of concrete blocks, boulders are sunk to alter wave direction and to filter the energy of waves and tides to minimize the erosional impact. The breakwater are the wave energy barrier designed to protect water area behind them from the direct assault of the waves, hence reduce their erosive power. There are 3 major types of breakwater, namely offshore breakwater structure, shore connected breakwater structures, and rubble mound breakwater structure. This is one example of the rubble mound breakwater structure. Sometimes it is made up of masonry, sometimes made up of boulders available nearby area to reduce the cost. This not only are used, they used to protect shore area, anchorage, harbors from the sea action, but also to create secure environment for mooring operating and handling ships. For mooring, operating and handling ships. Another type of structure is a purely protective structures or structures going to absorb the energy, going to strike is a sea walls. Number of places you can observe the construction of sea walls, and now we have different steps in sea walls that are generally utilized by the persons moving evening and morning near the sea coast, utilized as a sitting chair. So on one side this structure is going to protect the sea coast, on another side this structure is going to support the enjoyment of peoples. Here that was opposite direction. Here some ladder type of structures we are going to create so that people can utilize for morning and evening walk and enjoyment. These large coastal protection structures can be built using different types of construction materials such as rubble, mount, granite, masonry, sandstone, reinforced concrete, boulders, etc. If the material utilized for construction of such walls located nearby the shore, that will be economical, and if transported from far area, then it is costly and not economical. The sea walls are commonly built and run along the shorelines to prevent coastal structure and areas from the detrimental influence of the oceanic or sea waves, actions and flooding which are driven by the storms or tides. There are various arrangement or configuration that might be employed, including the curved face seawalls, stepped face seawall, rubble mount seawall, etc. Different type of seawalls we are having. Some of the seawalls are curved in nature, in section, curved in nature, both concave and convex, but generally we are making the convex structure as per engineering consideration. When the waves are coming here, then the distribution of the impact or stress or force transfer toward the specified side, and in this way this type of structure is going to protect the. You can see one walls where these ocean waves are going to interact, going to make impact on such walls. So sea wall structure is a structures going to protect the coastal zone by absorbing the energy of waves which are responsible for eroding the coastal zone. Beside this, we have sand dunes. It may be natural, and we are also able to create this type of structure. The sand dunes is going to minimize the impact and observe the energy of waves, divert the waves, and partially absorb the energy, break the energy of waves if present normal to the movement of sea waves or interaction of sea waves with dunes. Such type of structures located in coastal zone naturally is going to support the stability of coastal zone. Nowadays we are going to plant number of grasses and trees to provide the stability to such dunes. Such soft technique we are going to prefer to reduce such type of impact. Dunes also provide habitats for highly specialized plants and animals, including rare and endangered species, and it is important to consider dune structures when planting dune vegetation. And dunes are composed of the four dunes, that is the part that face the ocean, and the sand plain and the back dunes are utilized for such type of protection. The microenvironment of these dunes component limit the type of plants that can be searched properly. The protection, stabilization and restoration method utilize measure to reduce the transport of sand between, such as planting vegetation, constructing sand fences and selecting access area that avoids damage to dunes and dune vegetation from foot traffic of the peoples. Next structure is jetty structure. You can see here jetty structure, slightly elevated structure. This jetty structure is a long narrow structure that protect a coastline from the currents and tides. The jetties are usually made up of wood, earth or stone or concrete or masonry, and they stretch from the shore into the water. This type of structure is going to divert the movement of waves as well as break the impact of waves. Currents and tides of an ocean gradually wash away a beach or other features along the coastal zone, and this is called as the erosion break area. Strong river currents or waves are the waves of the seashore. This jetty protect the shoreline of a body of water by acting as a barrier against erosion from the currents, tides or waves. And the jetty is a breakwater structure, wave diverter structure. Some of the waves move in this direction, some of the waves move in this direction. In integration of all type of controls and all type of attempts, the effective action of the sea coast protection can be summarized as, besides the controlling coastal erosion, also require de-stressing of the people living close to the coastal landforms or coastal zone. The coastal area in several places are populated by human settlement very close to the shore, and time to time the peoples feel lot of stress concerned to such type of hazardous impact. Such human settlement need to be prevented properly, timely and carefully. The planting of trees close to the human habitats in coastal area protect from the degradation of the sandy soil fill coastal area, and it is necessary to grow saline resistant plant along the coastal zones such as coconut and others, palm tree and others, to protect the coastal zone. The assessment regarding extent of damage that may be caused by littoral drift for the design of remedial measures, and there is sufficient scope for using the natural beach material obtained from the littoral drift for continuous coastal protection along the long extent of the coastline. And use of natural heaps of sand and shingles to make the wall is an economical means of absorbing the energy, diverting the energy, breaking the energy of the waves, and thus protecting a coast zone. Hence, this is useful choice for the protection of coastal area. Available material such as clay, sand and shingles are economical for use due to reduced transportation cost. However, concrete is the most constructive material utilized for such type of protective structures like retaining wall for coastal protection, and growing of mangroves and building concrete sea walls or walls of the dense and durable rock blocks are other method of saving the coastal landforms from the effect of erosion and impact of sea waves. The sea wall should be designed based on maximum probable wave height and amount of energy and the distance of the impact and the location of breakwater zone, etc. Construction of wall of rocks, wave breakers not only save the coast but also serve as the means of protection from the impact of tsunami or waves. Depending upon the morphology of coast, rock walls can be built as close to the seashore as practicable or practically suitable. And this, in addition to this, the modern practice of preventing coastal erosion by the use of groyans should be followed by the plantation and others on the sand dunes, and they are to build transverse to the breaking crest of storm waves and anchor at the base of a suitable bedrock, and the beach can be protected by arresting the littoral drifts with the use of groyans or by artificially changing the beach. Groyans requires anchoring with the bedrock for placing the required angle to coastline along the construction of other structures and sand dunes. Friends, this lecture I have prepared with help of number of sources, knowledge base and partial supports from the engineering geology book written by Gangopadhyay and partial support from the another book engineering geology written by FG and textbook of engineering geology written by Kashavolu NC along with some materials from net and others. If we are going to conclude about this important aspect, we can say that the coastal erosion is a natural hazard to the people living close to the coastal land, and the longshore current then travels along the coast covering extensive distance play the most damaging role in the coastal erosion along with tides, along with tsunami sometimes, and the human activities such as mining, beach sand, dredging of shore area and also construction of building close to the coast make the coastland vulnerable to the erosion and enhance the erosional hazards. The principal protective measures for the coast close to the ocean ends, especially the beaches, include providing walls to save the sand of coastal zone from the waves and current action by means of groyans, gabions, wave breaker structures, jetties, etc. Areas near coast that are subjected to easy erosion should be barred from the human habitation, and use of geotextile tubes is a modern approach in this direction along with some soft environmental control measures like plantation of grass, trees, etc. Dear friends, in this class we have elaborated about harmful impact of sea waves in form of erosion as a major and partial as a sedimentation that we have not considered here, and effect of erosion on the coastal zone, landforms, migration and mitigation of such hazardous problem, then protective structures, type of protective structures and their work. Thank you very much for your patience.